So I'm going to be talking to you about what I think is a very powerful self-alignment device. It's a way to work the white space between companies. It's a way you can view risky situations before they occur. It's how to make sure your mega project might not become a mega failure. And hopefully at the end you'll be able to answer the question, what's in it for me, in terms of your own business values. Also, if you're a lead contractor or an owner, you might be able to use a system like this and the data that it produces to establish incentives or even awards for excellence among the suppliers that you have in your system that can execute that -5% or 0% project, not be one of those 50% ones we don't want to talk about. So also I want you to understand this is not project management. Interface management is a discipline that introduces, maybe think of it as a fourth and fifth dimension into the classical process management approach. So we'll be discussing the definition of interface management, its challenges, the key success factors, and overall to understand how you can manage a project with certainty. So the focus is on dynamics, and to understand this emerging discipline of interface management. We're going to be talking about alignment, disciplined approach to managing, and how to collaborate in an IT tool environment. So this is the definition of interface management. It's the information flow between major contracting parties on large, complex, modular-based construction projects. And if Alberto were to look more into modular construction, as Jeff suggested, this would be a good application to move into. So let's assume that you're the owner in yellow there, and that you have EPCs as shown. EPC 2 has independent projects. The independent projects might come back directly to the owner. There's additional EPCs, and some of those EPCs may have working relationships. There is not enough technical capacity in the world to support major oil and gas projects and a large-scale nuclear building program throughout the world. It takes the same kind of expertise to build a refinery as it does to build a nuclear plant. If nuclear comes back, and it probably will, we're going to have to collaborate like this in more places than the Middle East. I just had a note here that there is a white paper that Coreworx can get you that gives a detailed multi-year example of how this situation's already happened in the Middle East in the 2000s. Now, I mentioned the Independent Project Analysis Institute just a minute ago. That data correlates very well with what John said for the Construction Institute, in that the average project is about 40% over schedule and 40% over budget. So a $10 billion project might cost 14, and a 5-year project might take 6.5 years, and that's only if you're average. We have a root cause document that was written by one of the European regulators on a very large project done in Scandinavia that was not done according to plan. It's about 4 years overdue, and it's probably double in cost, and the only people that make money are going to be the lawyers, because it was a fixed price job. And so there's a learning. I've tried to incorporate the lessons learned there into my advisory work with Coreworx, but let me just read you a couple things here. Insufficient advanced planning and analysis, not completing advanced detailed engineering, not building a unified owner contracting team, organizational bottlenecks in fast-track projects, and governance failures. And there's 3 sub-bullets for each topic, so I won't read it all to you, but this was done with conventional fixed price costing and your classical level 1, 2, 3 contracting structure Level 1 was one country, level 2 was a second country, the level 3 was a different country, and it was implemented in a fourth country. So they're using 7 languages and memos when things don't go right, and kind of avoiding the problem discussion. And you can just imagine how significant those problems were. So the root cause of that was poor interface management. But it's not that easy to build an application to do this, because you have sort of like natural tension in these components. You want to be centralized, but the thing might be in some other part of the world, and the next one you do might be in a different part of the world. You want to be transparent, but there's all kinds of confidentiality agreements that have to be met with suppliers' technologies. You want to be able to have a global practice, but you want to be able to deviate in places where it makes sense to do something in a work environment where that practice might be more applicable. You have contract commitments to do sort of the minimum, but in the workplace there's detailed things that happen all the time that you have to be able to work out. So this is sort of the teeter-totter that makes people do this without tools very, very difficult. So the first condition for success is alignment. And the key here is, what are the acceptable tolerances? Do you want to know when you're $1 billion over, or do you want to know sooner than that? You have to understand the project objectives, and everyone has to understand their role. Now, just to give you an example in nuclear, or two, in a Navy nuclear program in the shipyard, the dry dock time is $60,000 a minute. And so there's a lot of planning done there, and it's all under government contract. But there's only 2 contractors in the world that do that: Newport News Shipbuilding and Groton, Connecticut's Electric Boat. And they've done the same job over and over again. They're constantly improving. It is construction, but it's construction of a class of ship, generally, or a refueling of a ship. So it's easier in that sense than construction. A nuclear refueling outage is done about every 2 years. We would bring in 2,000 people, tag out 350 tagging systems, maybe put 3,000 or 4,000 tags in the plant, do 20,000 work orders, test the system, start the plant up again in 21 days. And that requires team meetings, very good relationships between suppliers and contractors. And the acceptable tolerance was, we had a war room, and if anything wasn't going to happen within 2 hours of when it was scheduled, somebody came and got the outage director, and we worked out a plan immediately. But again, that's not construction. Nuclear construction can't even be done that way in the commercial industry. So although that's a very complex job, and we had a very high degree of alignment, you can't use that way for your business. So here's some factors that affect the alignment. The culture, I mentioned the 4 countries. That's part of it. There's language, there's attitudes and beliefs, but it's basically your work environment. Then the execution process itself has to match. Procedures have to match. Outlines have to match. And when you want to move from one process to another, or a process to a sub-process, everybody has to be literally on the same page. Because although we do this in online, a lot of IT type environment, paper is a very durable media, as I would say. And so you're going to see paper out there that has to be correct, and that's where this execution process alignment really helps. Also, you have to share information. This is the data structure. Everybody has to have the same framework, same kind of warehouse. If you don't have that, then you have the equivalent of the paper not matching, but it's in the computer, or you can't find it. And when systems aren't properly maintained, people might spend two days of their 8 hours every day looking for information, which kills your productivity. Then finally, we have barriers. These are complexities that occur that you may not have anticipated, but you need to be able to field those barriers and factor that back into one of these other 3 capabilities. Fix the culture, update the culture, update the execution process, or fix the data. So where do you really start? Well, back on that third slide, I had that picture of the EPCs and the owner. You have to go back to what are the project goals, who are all the people in the project, and you have to line up all those objectives. Then you document that, and just like John has an extremely good formula for the feed process, there needs to be a companion interface management plan if there's more than 2 Johns out there. Don't get me wrong, if John could do the work, I would be hiring John. You know, present company excluded. Then you go through the classical, what's the job role, how are we going to do the job, and you put that stuff into the system. And the system is set up to be, it's kind of like having a judge on your shoulder. And as we go through that, you might understand that a little bit. We need to surface conflicts, resolve conflicts, and be able to report on all the suppliers' progress. The second part is communication. This slide shows they didn't all count on 3 and they dropped the customer. Oh, you don't, can you tell that? That's a foot. Here's the feet. Yeah. The head's down here, you know, okay. This is the high cost of medical. And I want you to know, because the way the nuclear industry does human performance, when they come out and they're going to amputate an arm and they say, which arm is it, please initial, they're getting a nuclear best practices process of that. Yeah. Finally, in the details of the communication, we would have an interface register, which would list all the contracts and the contract interfaces. Interface points, which are physical locations where one contractor stops and the next contractor starts. And then based on those points, we'd have interface agreements on how the work would be done by phase through each major project. Finally, there'll be an information system that actually carries out those concepts. One system, or an overarching system, that centralizes the information, can be able to distribute that information anywhere in the world to any of the suppliers' home offices or whatever work locations have been established. It has to be a portal. It can have communication going each direction. It has to have business rules where the judge will rule in the favor of the person that's following the rule. Everyone's expected to behave the way the roles are defined and applied. If something happens that is unexpected, or something major that's happened that goes according to plan, there might be some type of notification, automatic notification to all the parties. And then you have a dashboard, which I don't really know of any place else in any industry where you have something like this, but it actually kind of looks forward into the way the system is being built and the change notices that are occurring. So you can almost smell a problem with that system. Here are some screenshot examples of the formal tools, the interface point, the interface agreement, the action item, and the change request. Each one of these has a separate workflow that gives each party a chance to define what they want, have it reviewed, have comments, log it, start using it, change it, and close it out. This is an example of the dashboard. You can pull various web parts from the system and build the type of dashboard that you'd like to have. And as the owner-operator, you could actually see the whole project in one of these views. Any of the EPCs can have their own report, or the report for them and their interfaces. And it can be, you know, I guess in the international colors, red is bad. So you can see there something that might be overdue. So you don't worry about so in the big nuclear fiasco, 2 months after something happened, they'd find out somebody made a mistake and why. This would flag something if an interface agreement wasn't done 30 days before the work starts. So it's more proactive and leading then the typical time is okay for collecting status, but if something's late, it doesn't say why, it just says it's late. So this is an example of getting into why. So there are many benefits here. You'd end up with, by the percentages that John was saying for better feed, you might be able to take that same number or maybe even double it for 2 Johns and the work in between, how much better their work was. Because the work packages would be better, the scope would be more clear. There'd actually be working relationships down at the L2, L3 level with peers from one company to the other, which is fairly rare to plan at the very beginning of a job. The overall planning process would be better, and you would understand how complex the work was. So I think, in general, it's going to reduce the uncertainties in a project and keep the project performing in a more narrow band of performance. It also allows you to take actions where you think actions need to be taken. The actions are in the system, and all of the transactions are recorded, so you can go play it back later and see what actually happened in a critical, say a milestone wasn't achieved, what happened with that. So in conclusion, the 3 key factors for interface management are alignment, communication, and coordination, and having a powerful information management system. We all know that projects potentially can go off track. Scope changes, markets change, people change. It's important that to ensure that key contractors are working on a project and are aligned together effectively. Clear roles and responsibilities, along with commitment in promoting open and effective communication to a team environment, is essential. Interface management is a comprehensive process for managing dynamic projects throughout the life cycle. This ensures consistent tools that help the owner and project team maintain a balance between scope, time, cost, quality, and resources. That's it.